Alright, let's take a trip. A very, very long trip. We're heading out past the familiar planets, past the majestic rings of Saturn. We're going to the seventh rock from the sun. Welcome to Uranus. It's a place that hangs in the quiet, cold twilight of our solar system, a world so far away that it appears as just a faint star to most telescopes on Earth. This is the realm of the ice giants, a completely different kind of planet from the rocky worlds like ours or the gas giants like Jupiter. Just how far are we talking? The sun's light, which takes about 8 minutes to reach us here on Earth, takes over 2.5 hours to get to Uranus. It orbits at an average distance of about 2.9 billion kilometers, or 1.8 billion miles. That's roughly 19 times the distance from the Earth to the Sun. This immense gulf of space means the Sun from Uranus would look like just an incredibly bright star, its warmth barely reaching the planet's cloud tops. Now let's talk size. Uranus is a giant, but not in the same league as Jupiter. It's an ice giant. If Earth were a grape, Uranus would be a large apple. It's about 4 times wider than our home planet, with a diameter of roughly 51,000 kilometers. You could fit about 63 Earths inside of Uranus. Despite this huge size, it's not as dense as you might think. It's the second least dense planet in our solar system, after Saturn. Its mass is about 14.5 times that of Earth, which is substantial, but spread out over that massive volume, it tells you the planet is made of lighter stuff than our dense, rocky world. It's mostly made of ices, water, methane, ammonia surrounding a small rocky core. Every planet in our solar system spins like a top as it orbits the sun. Most of them spin more or less upright, with a modest tilt. Earth has a tilt of about 23.5 degrees, and that's what gives us our seasons. Even the gas giant Jupiter is tilted by only about 3 degrees. But Uranus? Uranus throws all the rules out the window. It's the rebel of the solar system. This planet is tilted on its axis by a staggering 98 degrees. It isn't spinning like a top, it's rolling like a ball. It's literally orbiting the sun on its side. Why is it so tilted? The leading theory is a story of ancient cosmic violence. Billions of years ago, during the chaotic formation of the solar system, a young Uranus was likely smacked by a massive object, perhaps an Earth-sized protoplanet. This colossal collision would have been energetic enough to knock the entire planet over, changing its rotation forever. It may have reshaped its internal structure and perhaps even influenced the formation of its moons and rings. This bizarre tilt has profound consequences for what a day and a year look like on Uranus. First, a Uranian day, one full rotation, is surprisingly short, clocking in at about 17 hours and 14 minutes. When you think of planetary rings, Saturn immediately comes to mind, with its bright, glorious, icy system. But Uranus has rings too. They're just much more subtle. They're like whispers in the dark. There are 13 known rings, organized into 2 systems, an inner system of 9 narrow, dark gray rings, and an outer system with rings some reddish, some bluer in hue. They are composed of extremely dark particles, likely a mix of ice and radiation-processed organic material. They were discovered in 1977, not by direct sight, but when astronomers watched a star flicker as Uranus passed in front of it. Astronomers noticed the star's light flickered, indicating unseen rings. The rings are incredibly thin and narrow, some just a few kilometers wide. They may be relatively young, formed from the debris of a moon shattered by impact or torn apart by gravity. They are a delicate and faint feature of this already mysterious world. But Uranus is not alone on its journey. It shepherds at least 27 known moons. These moons are named after characters in the works of William Shakespeare and Alexander Pope: Titania, Oberon, Umbriel, Ariel, Miranda. For millennia, humanity knew of 6 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn. But that all changed on March 13, 1781. An astronomer named William Herschel, in his garden in Bath, England, using a powerful new telescope he had built himself, noticed a faint object. He saw a small, fuzzy disk that moved relative to the background stars. At first, he thought it was a comet. He reported his findings to the Royal Society, and astronomers across Europe confirmed that it was planetary. The solar system had suddenly gotten bigger. Herschel suggested Georgium Sidus, naming it for King George III, but the international community pushed for a mythological name. Johann Bode proposed continuing the mythological convention, naming the planet after Uranus, Latinized to Uranus, keeper of the sky. The name connected modern discovery to ancient myth and gave the New World a sense of mythic grandeur. For nearly 200 years, the details remained a mystery, until January 24, 1986. On that day, NASA's Voyager 2 made its historic flyby, humanity's first close look at an ice giant. The spacecraft had already visited Jupiter and Saturn on a journey that nearly a decade in the making. It came within 81,500 kilometers of the cloud tops and had only a few hours to collect data. It took thousands of images of the planet, its faint rings and its moons, and streamed them back across billions of kilometers. It measured composition, temperature, pressure, and mapped a wildly tilted and offset magnetic field. Voyager discovered 10 new moons and imaged Uranus's faint rings for the first time, fundamentally changing our picture of the planet. It revealed Miranda's bizarre patchwork surface and features like Verona Rupes, a cliff perhaps 20 kilometers high. Almost everything we know about Uranus today comes from those precious hours in 1986. Voyager transformed Uranus from a point of light to a real, tangible place. Its data continue to fuel decades of research and modeling. So, why should we care about a cold, distant planet rolling on its side? In science, the weird and the anomalous are often the most valuable. They force us to rethink our models. Uranus's extreme axial tilt, its bizarre magnetic field, its low internal heat and dark rings. None of these fit simple expectations. Yet ice giants like Uranus are common in the galaxy. Understanding them helps us understand thousands of exoplanets. To answer open questions, we must return. With an orbiter and an atmospheric probe, the next great flagship mission. The journey is long, taking over a decade. The spacecraft must be robust, with instruments to study atmosphere, magnetosphere, rings, and moons. An atmospheric probe would plunge in, sampling composition, temperature, and pressure, sending back a direct taste of an ice giant's air. A detailed magnetometer sweep could map the lopsided dynamo and explain its odd magnetic geometry. Close flybys of moons could reveal their geology, revealing the history of impacts and resurfacing. Spectroscopy would tell us what the dark ring particles are made of and how they are maintained. Giant planets are vast reservoirs of light elements, hydrogen and helium, perhaps even helium-3 in useful abundance. While atmosphere mining is currently science fiction, it reminds us these worlds could be resource-rich in a distant future. The technical challenges are immense. Long travel times, extreme environments, and complex mission design. But the rewards, revolutionary science about ice giants, better models of planetary formation, insights into exoplanet demographics, are enormous. In the end, Uranus is more than a ball of ice and gas billions of kilometers away. It is a symbol. It represents the unknown, the strange, and the unexpected. Its existence, hidden in plain sight for millennia, reminds us the universe is full of surprises. From Herschel's homemade telescope to Voyager and the probes of today, we build tools to peel back cosmic layers. This drive to understand is at the core of what it means to be human. We are a species that looks up and wonders. Think about that distant blue-green world, rolling silently through the dark.